Coding made easy.
So what's up everybody, this is Peter aka CodingMadeEasy coming to you guys with your next OpenGL Made Easy tutorial. And in this tutorial we are going to be learning about passing data from the CPU to the GPU. So essentially passing data from our C++ code to our GLSL shader code. So a few things before we actually get started. If you like my content, don't forget to hit that like button, don't forget to comment below, and if you aren't subscribed already, click the subscribe button and the bell so you will get instant notifications whenever I upload. The second thing that I have to mention is if you watch my last tutorial, you'll see things. I use some native types such as like unsigned int and float and so on and so forth. To remain consistent, I've changed them to the GL types, and I will be doing so from now on for the rest of this tutorial series. So if I do miss one here or there, just point it out to me in the comment section. So anyways, I don't want to waste too much time. So basically we're going to render the exact same triangle as we did in the last tutorial. The difference is that instead of specifying the vertices inside our vertex shader itself, we're going to pass the data from our CPU to the shader, and then it should work the same way. Now, as you can see in this file, I say coding made easy is great, and I did this for a particular reason. In the last tutorial, I told you that I would go over how to check for shader compilation errors in this tutorial, and I already have it done here, so I'm just going to go over it really quickly. It's fairly simple. So first, you just got to create an integer, sorry, and a char with a certain array size, and then we call this this function called glGetShaderIV. Now the IV stands for vector of ints, and that indicates the value that's being returned. But that doesn't really matter too much to us. In order to get the compilation status, first we got to pass in the ID of the shader we want to get the status from. We pass if we look at the parameters, we get the name, or what we're trying to actually extract, which is the compile status, and then this is the return value, so it turns an int pointer. So if it's not successful, then what we do is we say get shader info log. So therefore we pass in the shader ID, we pass in how many bytes we want to get from the info log. The next one is the length. If we put null pointer, it will autofill it for us. And then info log this is where it will actually put the data. So in here we're saying, hey, get the data, the info log for this ID for a max of 512 bytes and store it in this variable called info log, and then we display the info log to the actual console. And what I'm going to do is I'm just going to run this application with the text coding made easy is great, and because we have that text in there, then we should see compilation errors. So we're just going to wait a little while for this to start up. It's taking a long time, not sure why. Okay, so as you can see, the triangle isn't rendered, and it gives us the compilation error, and it says it's obviously a syntax error. And if we go back to our vertex shader code and remove this, and we save it and click F5, we shouldn't get any text at all because the code should be valid, and we get our triangle again. So put that code in, so if you have any compilation errors, you can spot them right away. So without further ado, let's jump into actually passing data from the CPU to the GPU. So first and foremost, we need to have a mechanism in order to actually pass the data from the CPU to the GPU, and that storage mechanism is called a vertex buffer object. So a vertex buffer object basically stores data for us on the GPU. So let's see how we actually create this vertex buffer object and how we actually pass data to this vertex buffer object. So what we're going to do is we're going to make a unsigned int, and we're gonna just call it VBO for vertex buffer object. Now after we create this, we're gonna make a call to GL gen buffers, and as you notice, it says buffers, which is plural. The reason why is it takes two parameters. So the first parameter wants to know how many buffers we actually want to generate. In this case, we only want to generate one, so we're just going to put one. And then this takes an int pointer on the IDs that it's going to return. So for example, let's say that we had an array of GL unsigned int, and we set this to 2. Then this would generate two vertex, or it would generate 2 buffer IDs. So basically it will generate the ID. We say we want to generate one ID, and we're going to store it in this variable called VBO. Simple enough. And before we continue with that, what we're going to do is we're just going to cut this code, and we're going to put this vertex, we're going to put this vertex information into a variable. Now I already have it somewhere. Yes, I have it here. So I'm going to just put it here. So these are the exact same vertices from this file right here. So you can pause it to confirm, but I'm not lying. It's the exact same data all in one array. So this is the first 3 points, the second 3 points, and the third 3 points. So we have our vertices data. So this data is on the CPU, and we want to pass it to the GPU. So after we've generated our buffer, then we have to do something called binding our buffer. So we're going to do that by making a call to GL bind buffer, and we're just going to say GL array buffer, and we're going to just put VBO. So what's happening is that OpenGL has many different buffer types. So it needs to know that, okay, we've generated a buffer, but what buffer type is it, and what do we do with it? So basically, I'm going to make this really simple. So there's multiple buffer types, right? So right now there's nothing assigned to this target GL array buffer. So when we say bind buffer, we're saying that this vertex buffer object is currently assigned to this target GL array buffer. So any changes that we make to the GL array buffer is going to be changed on this vertex buffer from now on, right? So as I told you before, OpenGL is a state machine, so everything from this point forward, anything that affects this GL array buffer or anything that targets it in any way, shape, or form is going to be using this VBO that we've just created. So that's what bind buffer does. And the last thing we have to do is we're going to just say GL buffer data. So we're just going to put GL underscore array buffer. So this is going to say, okay, our target is a GL array buffer, which is this VBO that we've created here. And then we're going to, it wants to know, the next parameter wants to know the size of the data we're passing. So we're just going to use the size of, and we're just going to put vertices. And then we're going to, it wants to know the actual data we're passing. So we're passing the vertices. And then the last thing it wants to know is the usage. Now in this case, we're just going to put static draw, which means that we're never or rarely going to be updating this data that we're passing to the shader. Now why does OpenGL want to know this? The reason why is it wants to know where to store this data in the GPU. So in this case, since we set it to static draw, it means that we're rarely going to be updating this value, which means it can put it in a place in memory that might not be the fastest place to access. Whereas if we change it to something, a different type, that requires us to write to it all the time, it's going to put it in a place in GPU where we can write to it really fast and the GPU can read it really fast. So that is what this does. So what happened, what we did with this function is we said, okay, our target is a GL array buffer, and we bound the vertex buffer object to this array buffer. So then we're going to pass the vertices to this VBO. So that's basically what we did. So now we've passed the data to the GPU, and you might be saying, oh, that's great, that was easy. But it's not as simple as that, right? Because if we look at this, right, we specified these values as vertices, but how does GLSL really know these are vertices? What is this? These are just a bunch of numbers, right? As far as GLSL is concerned, it's just a bunch of numbers. It doesn't know how to interpret those numbers. For all it knows, these numbers could be color, they could be position, they could be anything else, right? And so we need to basically tell GLSL what to do with this data and where to put this data in the GPU. So what we're going to do is we're going to go back to our Vertex shader and we are going to do something that might look a bit weird, but I'll explain it in just a second. So we're going to put layout, we're going to say location equals 0 in vector3 position, and we can delete this right here. So basically what's important to take from this is location equals 0. So we're basically saying that this variable that we've created right here is in storage location number 0. So whenever we reference storage location 0, we're saying that we want to input data into position. And as you can see, we put the value in, which means it's expecting input from the CPU. So we're saying that we're expecting input from location number 0, and you're going to see what this means in just a second. So if we go back to the code, we have our data stored, but in order to actually specify how the data works, we need to specify that information in something called a vertex array object. So we create one by creating an unsigned integer, and we're just going to say VAO for vertex array object, and what we're going to do is we're going to generate it. So we're just going to say GL gen vertex arrays, and as you can see, it's plural just like gen buffers. So it wants to know how many vertex arrays you want to generate. We're just going to say 1, and then we're going to pass in a reference to our vertex array object, and so it's going to generate 1, and it's going to generate one ID for the vertex array object. So once it's done, what do you think we need to do? We need to bind to it because OpenGL is a state machine. So we're going to say GL bind vertex array, and we're just going to pass the vertex array object. So now everything we do from this point on that targets a vertex array object is going to affect this VAO that we've just created right now. So what we have to do right now is, now that we have this bound, we have to actually tell our vertex shader how to interpret that data and where to put that data. So we're going to do that using a function called GL vertex attrib pointer, or it stands for attribute pointer. And so this takes 6 parameters. So the first parameter is the storage location that we're referring to. So that location we created here. So we're going to say that we're referring to storage location 0. The next thing is the size of the data, right? So one thing to note before we even continue, well, we're going to set this to 3 for now. Before we even continue, GL vertex attribute pointer uses the currently bound GL array buffer, right? So because it uses the data, from the currently bound GL array buffer target. So since this VBO is currently bound, then we're referencing, or we're referring to this data which we've passed in over here, right? So we're referring to our vertices. So this parameter is saying, okay, with the data in the vertex buffer object, what is the size of the data that we want to put into storage location 0? And since storage location 0 is a vector 3, we want to put in 3 pieces of data. So what this is saying right here is saying that with this data right here, we want to take 3 pieces of data from it. That's what it's basically saying. So the next parameter is the type of data that actually exists in the vertices. So we're just going to put GL float because it's floating point values. The next thing is whether we want to normalize it or not. So it wants to know if we want, if these values were not between 0 and 1, if we set this to true, then it would automatically convert it to a value between 0 and 1 for us. In this case, we've already normalized it because the values are between 0 and 1. So we're just going to put GL false. So we don't want it to do anything with the values we pass in. And the next thing is the stride. We're going to set the stride to 0. Basically, what the stride means is that once we get the data, how much data do we want to skip after we start looking for the next data? So for example, let's say that we set the stride for 1. What this would do is it would read the 3 values, it would skip the value, it would skip 1 value, and then read the next 3 values, skip 1, and then read the next 3. In this case, we don't want to skip any values, so we're just going to set it to 0. And the last thing, the last parameter takes a void, so we're just going to put GL void pointer, and we're going to set it to 0. And this is just takes the offset, so it wants to know where we should start reading the data from. In this case, we want to start reading it from the beginning, so we just set it to 0. So if we go through everything, we're saying that with this, we have the, okay, let me backtrack. So GL vertex array vertex attribute pointer basically reads the data from the currently bound GL array buffer target, right? So it has this data. It just wants to know what to do with it. So we're saying we want to take this data and put it in storage location 0. We want to take the data in batches of 3 at a time, and the data is floating point values. No, we don't want you to normalize it for us because it's already normalized. No, we don't want you to skip any values between the batches, and we want you to start at position 0 within the array. And that's all that we need to do. So last but not least, we're just going to say GL enable vertex attrib array. Sorry if I can type. And wait, what am I doing? Sorry, attrib array, and we're just going to set 0. So basically, we've said that we want to we've set how location 0 should interpret the data, and then we've enabled it so that it can now receive that data and actually use it. So now that that's done, everything should work, right? So let's click F5 and let's see if it actually worked. And we should see a red triangle after the window shows. Why is it taking so long? And as we can see, we have a red triangle. So I just want to go over, and basically that's it. So we've passed the data and we've told GLSL how to actually interpret the data, but I just wanted to go over it one more time just in case you guys missed it. So we have this data right now. We want to pass this data to the GPU. So what we got to do is we got to create a vertex buffer object, and we want to set the GL array buffer target to our vertex buffer object. And then we use GL buffer data to actually, because right now we have an empty buffer. So we use GL buffer data and we say, hey, we want to pass the vertices data to the GL array buffer target. And what is that target? That is the vertex buffer object. So it's going to pass vertices to the vertex buffer object, and that's going to store the data on the GPU for us. Cool. So then we've created this vertex array object, which is used to determine how to interpret the data. So first we've generated it, we've generated the ID, and then we bind to it. So any change from this point on, anything that needs to access the vertex array object information is going to use this VAO. And then we say GL vertex attribute pointer. So this is what actually specifies how the data should be interpreted. So we say that, hey, we want to interpret this data in location 0. We want to get the data in batches of 3. What data is it talking about? It's talking about the data that is currently in the GL array buffer target, which is the vertices that we pass to it. So it's saying that it wants to get this data in batches of 3. What does this data contain? It contains float. so floating point numbers. So we set that GL to float. No, we do not want to normalize it. No, we don't want to skip anything between batches of data, and we want to start at position 0 like so. And then we just enable location 0, and so when our shader runs, it's going to say, oh, okay, location 0 is enabled. How do we interpret it? Oh, we specified that in GL Vertex attribute pointer, so it's going to pass that data into position, and then we pass that position to our GL position, and as you can see, we get that nice red triangle. So that is it for this tutorial. I hope you enjoyed it. I hope it wasn't too confusing. In the next tutorial, we're going to continue working with Vertex buffer objects and Vertex array objects. They're the foundation. They're pretty much a foundation of passing data between the Vertex, between the shader and the actual code. So learning how they work and so on and so forth is going to be crucial to your OpenGL experience. So we're going to continue playing around with it, do a little bit more complicated stuff as the videos go on, and then we'll jump into some other stuff a little bit later. So I hope you enjoyed this. Don't forget to comment, like, and subscribe, and bye for now.